Now the cylindrical coordinates will look familiar because this is just the three-dimensional counterpart for the polar coordinates that we learned back in Calculus 2. Now in this three-dimensional version of the rectangular coordinate system, we're looking at the point P that has been projected vertically onto the XY plane. And here we have the triangle formed in the XY plane whose sides are the X and Y coordinates of the point, and the hypotenuse of this triangle is called R. And the sine of the angle theta is the opposite over the hypotenuse, which we can solve that for y to get y equals r sine theta. And likewise, the cosine of the angle theta is the adjacent over the hypotenuse, which would be x over r, which gives the x as r cosine theta. That's the same thing that we had in polar coordinates. And the z component is the same in the cylindrical and rectangular coordinates. Now in the right triangle, we can use that to find the angle theta from just the y and the x. The tan of theta in that triangle is the opposite over the adjacent, or y over x. And so we can do the arctan of y over x to find the angle theta. Now, remember, the arctan function always gives an angle, but in quadrants 1 and 4. So, obviously, if we have points in other quadrants, we're going to have to make some adjustments. And the Pythagorean theorem on this triangle gives us x squared plus y squared equals r squared. Now, whether r is positive or negative is going to have to be contingent on what the point is we're trying to find and the angle that we're using. So they all have to work together. So here's how we could use the formulas that we just derived to convert this point into its cylindrical coordinates. So using x squared plus y squared equals r squared and substituting, we get r to be either 2 or negative 2. Now, which it is depends on the value of theta that we use. Now, we'll substitute into the arctan of y over x to get the value of theta. And since the point we started with, 1 and square root of 3, was in quadrant 1, pi over 3 is also in quadrant 1. We know to use the positive value of r. And so this is our point in cylindrical coordinates. And of course we could just use our TI-89. See how you type the point with the brackets around the components, and the cylinder command you can find under the catalog in the C's. Now this one we will convert from the cylindrical to the rectangular using x equals r cosine theta. Substituting, we get the x value, and using y equals r sine theta, substituting, we get the y value. And of course the z is the same as it is in the original point. And also there's a command to convert to rectangular coordinates, and you just need to know that to type the angle symbol on your calculator, the blue up above the EE key is how you get your angle bracket for the angle